In this lesson, I'm going to show how to relate force and mass units. To relate units, start with Newton's second law of motion. The sum of forces on a body is equal to the mass of the body times the acceleration of a body. Next, recognize that the magnitude of units is defined by human beings. At one point, people decided that 1 unit of force, i.e. 1 Newton, by definition would be the amount of push or pull that would accelerate 1 unit of mass, that is 1.0 kilograms, at a rate of 1 meter per second squared of acceleration. And the key idea is that this is a definition and you have to memorize this or look it up. So again, by definition, 1 Newton of force is the amount of force that will accelerate 1 unit of mass at a rate of 1 meter per second squared. Next, take this equation and divide this term on the left-hand side by 1 Newton and divide the right-hand side by the same thing, 1 Newton. Now let's clean this up. Newtons cancel, and 1 divided by 1, we get 1.0 on the left-hand side. On the right-hand side, we have all these 1s. We don't need to write those down. So we simply write down kilograms from right here, meters from right here. Second squared we'll write down here. We'll leave out the 1 and then we'll write Newton down here. So now we've defined a conversion ratio. 1.0 is exactly equal to a kilogram meter per second squared times Newton. This is how units were defined historically in the SI system. In the English system, people made a different definition. In particular, they said, let's define 1 unit of force, so 1 pound force. By definition, this will be the amount of force that will accelerate 1 unit of mass, so 1 pound mass. And again, this is a definition. You can put whatever you want in here. And what was decided was 32.2 feet per second squared. And again, this is just simply a definition, something you have to look up or memorize. And the reason 32.2 feet per second was put in here is that this is the acceleration of a body when it's falling, when gravity is the only force on it. So it's kind of a natural number to pick. To derive a conversion ratio, we do the same thing we did before. In particular, we're going to divide both sides of the equation by 1 pound force here, and over here we'll put in 1 pound force. Then we'll clean it up. Pounds force cancels. We get a 1.0 down there. Excellent. Pounds mass come into the numerator. There's pounds mass. Feet come into the numerator. Pound force and second squared go into the denominator. So we have pound force and second squared. And we have to remember to pick up this number, 32.2. So let's slide that in there, 32.2. And there's the conversion ratio we use whenever we're using English units. And it has this number 32.2 that appears because of the definition. And lots of conversion ratios have numbers in them. 1 foot equals 12 inches will give us the number 12 when we do the conversion ratio. And now there's another conversion ratio which is also important, and this is also when using English units. And this definition that goes here is that 1 pound force, by definition, is the amount of force which will accelerate 1 slug at a rate of 1 foot per second squared. In this definition, The only number that appears is 1, so I can write down the conversion ratio by inspection. So I have 1.0 equals slug times foot second squared, and I bring pound force down to the denominator, pound force. So there's a third useful conversion ratio when I'm using my mass units in slugs. In summary, force and mass units are related with Newton's second law of motion, shown here. We start with a definition. By definition, 1 Newton of force is the amount of force which will accelerate 1 kilogram at this rate. Or 1 pound force is the amount of push or pull that will cause this amount of mass, 1 pound mass, to accelerate at this rate. Once we have the definition of the force unit, then we simply use algebra to derive out a conversion ratio. And the conversion ratios are listed in this column. And I don't remember or memorize all this stuff. All I do is remember the force units and remember how to do algebra. And remember the force units are defined with Newton's second law of motion. I hope this makes sense, but if you can get this idea down, it will really help you when you're doing equations that involve both force units and mass units. We hope this lesson has been very useful. Thank you very much for listening.